Right, welcome back, grade 12s. With reference to the sketch, no, before even reading the question, aren't these looking a bit samey by now in a good way? They're two triangles. Look, there's a line segment that's common to both of them. So we'll probably work in the one triangle. Looks like the bottom one's got more information, and then go into the top triangle, right? Maybe we're starting to get a sense of that. And we know that we're going to use, the cos rule or the sine rule, definitely not the area rule. Didn't ask anything about areas here. Another thing here is, we've been given another isosceles triangle. So we can start filling in a whole lot of other angles. So if that's y, this must also be a wonky y. And this angle at the bottom here must be 180 minus 2y. Because we've been doing a few of these. So you're kind of going, well, they must add up to 180. And we've already got 2y. So we need 180 minus 2y, right? Maybe we're starting to get that sense. Then we start reading the question. Because the question is going to guide what we're going to do and not blindly use the sine or the cos rule and then what. Well, in the top triangle, there's a right angle triangle. So already sine, cos, or tan just directly are looking like they're going to be used. And there's a tan x there and there's an x. Oh, look, opposite over adjacent. So maybe we can start getting a sense of where we're going already. But let's just work in the bottom triangle. We know that we're going to work there to move into the top. So in the bottom triangle, we've got side angle side, included side to find this opposite side QR. We've also got a square root here, and we know that the cos rule has that kind of a squared equals this squared plus this squared minus something else. So if we wanted to find a side, we would be taking a square root. So that probably guides us into using the cos rule in this case rather than the sine rule. We could go QR over sine 180 minus 2y. And things would cancel out nicely. But because of that square root, I'm thinking cos rule. So using our cos rule, again, by now, hopefully you've got a nice sense of it. You used it last year. That we've got something squared. Well, wait. I'm losing a sense here. QR squared, right? That's the one that we want to find. So then we must work with this side angle side kind of opposite it. So QR squared equals a squared plus a squared minus 2aa cos the angle in between. Okay, right, cos rule, straight up, getting used to it. And let's just simplify some things here. A squared plus a squared is 2a squared. That's 2a squared as well. And we've got cos, but 180 minus. Cast diagram helps us think through this quickly. Perhaps you use the graph to see it as well, but the same idea. And we're in the second quadrant where cos is negative. So therefore, if we change that to cos 2y, this must be negative, making this whole term positive. Okay, so we've got 2a squared cos 2y. Now let's just look where we're trying to go to so we can save ourselves some time and possibly some energy. So we're trying to get here where we've got an a outside and the square root of everything else. So QR squared, we're going to want to square root both sides in a second. So let's take out a squared as a common factor. And we're left with 2 plus 2 cos 2y. So I'm sneakily looking where we're trying to get to so we can start making it look as samey already. And therefore, if we square root both sides of this equation, then we'll be left with a square root 2 plus 2 cos 2y. We're multiplying, so we can just take the square root of each of these. Okay, so it feels like we're almost there. We just need to get ourselves a tan x. Well, earlier we already spotted that we're going to be using that because here's x, this h is opposite, and this side of the triangle we just found is the adjacent. So therefore, we can say that, where did I want to do this? Over here. Here's a nice little spot. No, let's see if we can do it here because there's still another part to the question. We're so lucky. So in that top triangle now, tan x is opposite over adjacent. The adjacent is QR. While the equation's so simple, I want to rearrange it or manipulate it in such a way that h is the subject of the formula. So h is QR tan x, and we can just sub in QR, we know, is this big mess over here. So a square root 2 plus 2 cos 2y times tan x is h, which is what we know it should turn into. Okay, so we're kind of looking back and forth, and as things kind of developed, they started heading towards our answer. But we're mindful of that from the beginning. Okay, now the next part says, use the result in A to show that h equals that lovely term over there, 2a cos y tan x. Now what we might notice here is that we've only got a single kind of, not term, but we've only got a single y. We don't have 2y as we had over here. So we're going to have to use our double angle formula. So we know that h equals a square root 2 plus 2. Now that cos 2y, we're going to have to change using one of the double angle formulae. And then tan x is going to be outside here. So there's nothing to do with the tan x because there's tan x, there's tan x. So that's going to stay the same. The a is already there. So basically we're just going to have to get out a 2 in some ways and cancel out some other terms here. So the question always with the cos is, which one of those double angles are we going to use? Well, we've got 2 plus 2 times something. We're going to distribute this in. No matter what we choose, they're going to be 2 terms. So therefore, the one that I'm going to choose is the one with a minus 1 in it, because then that minus 2 and that 2, well, that's going to give us 0, leaving us just this term, which means we must use the 2 cos squared y minus 1. Okay, pause, and hopefully you see it there, the idea of which one we're choosing and why. It's always the question. Okay, so h equals a. Well, now we've just got, we're going to distribute. We already chose it, so the 2's would cancel. Underneath the square root, we're just left with 4 cos squared y. We've got the tan x outside. Well, now life's easy because a is a. The square root of a product is just the product of square roots. So the square root of 4 is 2. Square root of cos squared y is cos y. And tan x is just tan x. And lo and behold, that's what we're trying to find. Okay, that was a whole lot of fun. And we just squeezed it in before going behind my head. So that's always impressive, right? I'll see you in the next one.